Hi there, I'm John McMillan, and welcome to this edition of PCB Tech Talk, the podcast where I'll be talking about design tools, the EDA industry, and the questions you've been asking. I'll be bringing in special guests from time to time, including subject matter experts and EDA industry leaders. So be sure to subscribe to this podcast and let me know the topics you'd like to discuss and if you'd like to be my guest right here on PCB Tech Talk. Today I'm going to talk a bit about advancing and emerging technologies that are evolving, being implemented, explored, and under development. So let's jump right in. Do you remember when the hottest technology startups were networking companies, designing bridges, routers, and switches? The race was on to equip internet service providers, and yes, I do remember dial-up and companies like CompuServe and AOL. My first job in this emerging high-tech industry was in the early 90s on a design team designing an asynchronous transfer mode router for a startup company. This was a very exciting time for startups, IPOs, and even day trading, particularly in the networking equipment and internet technology space. Fast forward a decade or so after that, cell phones, I'll say flip phones, were booming, and a decade later, in 2007, the first iPhone was released. Since then, the technology and features and functionality and the infrastructure has just exploded from there. In fact, there's a very good chance you're listening to this podcast on a smartphone or other smart device. Well, so what's booming today? It's pretty easy for me to call this the era of the Internet of Things or the Internet of Everything. The buzzword is smart, the smart device, the smart home. From electric cars to every kind of wearable you can imagine era. Virtual reality and gaming, drones, the list goes on. In this podcast, I thought it'd be interesting and informative to discuss some of the types of components, products, and technologies that are evolving and emerging. That is, what are some of the key technologies and products that today's startups, or new or emerging technologies in new or existing companies? There's a lot going on in electronics design, and I expect some of these technology areas or products may surprise you. Are smart backpacks a real product category? Are smartwatches, 3D printers, wireless earbuds, and wireless speakers, or even drones now commonplace? Well, yes, but even so, their features and functionality are continuing to evolve, and new companies are emerging. That's right, highly funded startups are even designing CPUs and chipsets aspiring to be the next ARM or the next Intel. So let's start by talking about chips. A lot of new technology, fabless companies are emerging. Fabless, of course, without fab, which refers to the methodology of outsourcing the manufacturing of silicon wafers, which hundreds of semiconductor companies do. That is, they focus on the design, development, and marketing of their products, and they form alliances with silicon wafer manufacturers or foundries. These fabless companies are launching new components like configurable ICs that combine power, analog, and digital circuitry, creating a variety of power circuits. IC companies are working on new architectures and systems aimed to significantly change data processing for the IoT age by reducing the power and cost that's associated with applications like voice control, health monitoring, and industrial vibration monitoring, just to name a few examples. By developing reconfigurable analog signal processing circuits as integrated circuits and intellectual property, new ICs and custom ICs for IoT, virtual and augmented reality, automotive, smartphones, personal computing, wearables, and the list goes on. The number of startups developing ICs may surprise you, with design technologies that increase functionality, reduce footprints, and reduce power consumption and cost. What about AI? That is, artificial intelligence. I remember when I was younger, artificial intelligence seemed more like fantasy or sci-fi. You may remember the movie entitled AI, Artificial Intelligence, back in 2001, where a robotic boy becomes a bit too real. Well, today, artificial intelligence is becoming more reality than ever, and in many areas of technology, some of these areas that may even surprise you. This includes artificial intelligence chip processors that are being developed for deep learning, for computer systems that are able to perform tasks that normally require human intelligence. Things like speech recognition, visual perception decision-making, and even translation between languages. And artificial intelligence for technologies for smartphones, security and surveillance cameras, servers, robots, drones, wearable devices, and of course, autonomous driving. Technology is being developed for artificial intelligence use with augmented reality, where, for example, wearing augmented reality glasses in a museum is providing you with the complete history of the painting and the artists for the artwork that you're viewing. Or viewers at a building site being able to see a complete set of blueprints for a structure being built, or the ability to precisely identify where the pipes and wires are in an existing building. I've not heard as much as I used to about smart glasses, but make no mistake, companies are taking augmented reality and the applications for reality for smart glasses to the next level. Expect to see more and more applications with artificial intelligence in the future, and it will also come up more in this podcast. The technology for smart glasses is continuing to evolve, such as the development of special gratings and waveguides to deliver images from a display engine located in the glass's frame directly to the wearer's retina, aiming to eliminate the diffraction challenges associated with pattern artifacts and rainbow effects. That is, clearer and brighter images with the focus based on aesthetics and that are color balanced, high definition, and distortion free. Several new technologies span multiple applications. Let's jump into drones for just a moment. How about those drones? Do you have a drone? I have stood outside in my own yard and heard the buzzing of drones overhead from time to time, even buzzing around at night with flashing LEDs like a spaceship. Okay, maybe not like a spaceship, but yes, techie folks and hobbyists, even non-techie folks, have taken to flying drones and even racing drones as a hobby at maker fairs. But the uses and technologies for drones is just scratching the surface of what's possible. For example, imagine drone cameras with built-in vision processing technology and intelligence that enables it to locate and track a missing person in the woods or lost at sea. Or vision processing technology with the intelligence to not merely capture an image or video, but understand it, using deep learning to identify what it sees and even assess the risk potential and so on. Or drones that track you yourself, determining routes and safe passageways. Maybe you're lost in the wild on the Pacific Crest Trail, or perhaps a fireman fighting a wildfire where an eye in the sky can direct you or help you make a decision that saves your life. Power line, cell tower inspection. I expect we'll be seeing a lot more drones in our future in various applications, and not surprisingly, drone navigation and drone collision avoidance systems. Cameras, not just for drones, are evolving as well. Well, we've all seen on the evening news where authorities have to go back and look at the security camera footage after a crime has been committed. Well, imagine a drone, or better yet, a city with deep learning and vision processing cameras where intelligence in the camera can quickly identify an illegal act, access a database in the cloud of photos and mugshots, and alert the police to the likely suspect. How about cameras that recognize a medical emergency, an accident, natural disaster, or another out-of-ordinary event, and then immediately alert the appropriate first responders? Imagine cameras that detect the traffic volume and optimize a traffic signal's light duration. And for the home, are you ready to let cameras monitor you around the clock, control your lights, locks, air conditioning and heating, intrusion alarm systems, smoke and fire detectors, baby and infant monitors, doorbell and exterior and interior security cameras, all of your smart home devices? Imagine artificial intelligence detecting the hazardous behavior in toddlers in your home, alerting parents that their newborn is in distress, monitoring and reporting that your pet is getting rowdy and about to turn the couch cushion into a chew toy, or identifying when the resident may have taken a fall or be having a medical emergency. New technologies for cameras with vision processing and intelligence, deep learning that are aware, assess, and even make decisions based on what they detect. How do you feel about autonomous driving? How about the use of solid-state photonic beam-steered LiDAR for artificial intelligence and other applications? If you're not familiar with LiDAR, it's a surveying method that measures distance to a target by illuminating the target and pulsed layer light and measuring the reflected pulses with a sensor. Differences in laser return times and wavelengths are then used to make precise digital 3D representations of the target. So as you can imagine, this highly accurate mapping is being used for transportation, security, and of course for navigational use in assisted and autonomous automobiles. And I think it's worth mentioning that this type of mapping and sensor technology includes areas such as optics and photonics and optoelectronics. Think about technologies for machine learning, artificial intelligence, beyond mapping, technologies that can analyze the driver's state, the road conditions. How about sign detection and recognition, lane determination. I'm definitely ready for a technology that can find me an available parking space. How about deep learning and vision processing that can detect the passenger load and adjust the suspension to accommodate it? Or how about determining the optimum firing sequence for airbag deployment based on individual passengers and the direction of impact? These are all technologies that are being developed. Machine vision is also becoming reality. That's more than just cameras. Technology that enables machines to see with advanced sensors and systems based on asynchronous pixel sensor technology. Essentially, image censoring and image change reporting that is close to a biological model, enabling machines to react much, much faster, safer, and more intelligently and more autonomously than ever. How about gesture recognition for in-car controls that free the user from looking and reaching to physical buttons or touchscreen interfaces? Technologies like mid-air controls aim to make the driving experience safer by enabling drivers to keep their eyes on the road while still maintaining intuitive control of infotainment and audio systems. Is immersive holographic interfaces and augmented gesture control with natural tactile feedback next? Maybe those scenes from the 2002 movie Minority Report and the 2010 movie Iron Man 2, where the main characters engage with holographic gesture-based interfaces, are not so far from becoming reality. I don't know about you, but I'm seeing a pattern with technologies related to smartphones, especially with millennials that seem to be turning us all into mobile photographers and videographers. I was at a concert recently and found myself actually distracted watching attendees taking pictures and recording video of the musicians and, of course, lots of selfies. New technology in smartphone cameras, that is, terms like dual folded optics and actuation, depth mapping, image fusion, that is, algorithms that fuse two images to create a better quality image, and transition smoothing. But this photo phenomenon is pushing new camera technologies to include advancements like smooth continuous zooming and even automatically adjusting lighting conditions to capture the best images possible, even better than what we see with the naked eye. So here's another question for you. How would you feel if your smartphone was watching you? It's no mystery that mobile and wearable devices are continuing to evolve in ways that most folks hadn't even imagined. Look how quickly devices have gone from passcodes to fingerprint scanning to face recognition. Now, new technologies that use MEMS, that is, micro-electromechanical systems, like ultrasound transducers for ultrasonic gesture recognition, is being developed for use in mobile and wearable devices that actually detects and tracks user gestures in 3D space. How about cameras that use a combination of object recognition, image processing, and deep learning tools together with spectral analysis that enables cameras to automatically identify objects and determine their chemical composition from a distance? A hyperspectral image sensor that can not only be used for spectrometric analysis of materials such as food, but can also capture images in very low light. Not surprising in this era where more and more smart devices like smartphones and smart glasses and every kind of wearable you can imagine is how critical that power consumption is. These mobile and edge devices are always on and always aware. So technologies that improve power efficiency and reduce overall power consumption, enough to even support the next generation of devices that are supporting machine intelligence, that require machine learning and deep learning, the artificial intelligence. These devices will not only be smaller and have fewer components, they will be more power efficient and provide consumers with significantly longer battery life. To meet these requirements, the next generation of IP and components like microcontrollers and processors are being developed to support DVS, dynamic voltage scaling, that's insensitive to process variations, inaccurate device models, and path delay variations. Advancements in devices from embedded FPGAs to SOICs are being developed for scalability, low power consumption, multiple clock domains, and even embedded RAM. Are you starting to notice some trends in these new technologies? Lower power, smaller devices, greater pin efficiency, bandwidth and throughput, support for artificial intelligence? Hand in hand, there are advancements being made in SerDes interfaces and wireless multi-gigabit connectors. With technologies that aim to eliminate wired connectors and the frustrations associated with today's wireless communications, design issues with connectors, especially related to EMI, RFI, and ESD, have only become more challenging and communication speeds have increased, especially for today's large file, fast data transfer demands. The race is on with technologies targeting to eliminate these issues through contactless connectivity. And these are connectivity technologies that can securely and reliably transfer huge amounts of video and data between devices with unprecedented speed. Are we seeing an end to what we refer to as traditional connectors? Just imagine no more mechanical failures from the wear and tear of repeatedly connecting cables or pins, the prevention of RFI and EMI signal interferences, and placement anywhere. That is, they don't have to be near the edge of the device, and they can take up a fraction of the printed circuit board space, and they'll be sealed inside the devices, protected from exposure. Or how about networks completely free of physical connections? What we're talking about is wireless power. Uninterrupted RF to DC, radio frequency to direct current power. It's not so hard to imagine sensors and IoT devices without cords or docking needed for charging. But what about no longer needing to replace batteries and remote controls, smoke detectors, or wireless security sensors on windows and doors and more? Wireless power will be a real game changer. Let's talk some about LEDs now, light-emitting diodes. From Cree to Hue, companies are developing LED bulbs with new methods to make them brighter, smarter, and cheaper, and for every application from automotive to industrial and commercial. As LEDs become more efficient and brighter and power consumption less, they can further reduce energy cost and battery life of everything from residential lighting to consumer electronics. How about organic light-emitting diodes, OLED technology, that's being developed for use in displays and lighting industries including tablets and TV? Just imagine foldable, rollable, and stretchable OLEDs that will enable new types of devices in formats and with image quality that we can't even imagine today. That's pretty exciting stuff. Do you have a Fitbit or other health tracker? Is it a separate device? No one is likely to buy a smartphone today that's not equipped with a high-quality GPS and digital camera. In the future, you will likely feel the same way about your smartphone being equipped to include technologies that include medically accurate health monitoring sensors. Imagine a health monitoring sensor in your smartphone that is simple, accurate to use, and without the need to wear a cuff or a strap. Sensors that measure blood pressure, heart rate, blood oxygen levels, body temperature, and even respiration rates, all by simply placing your finger on a sensor on your smartphone for 60 seconds. In the hospital as well, disposable patches and sensor pads using RF are providing monitoring sensors that eliminate cuffs that typically have time-based monitoring systems. New technologies aim to provide continuous, non-invasive health monitoring. New technologies that improve the patient's clinical condition by enabling arterial line grade monitoring. From fabless ICs, high-capacity RAM, advancements in DRAM and NAND, memory to low-power and battery-free wireless charging, and even alternate power, state-of-the-art MEMS, smart machine learning, artificial intelligence, and from the expanding technologies for smart homes, automotive, medical, drones, and robots, the future technologies and electronics shows no limits in the environment and technologies that they are developing and evolving in. These technologies will also require an increase in wireless local area network deployment, and not surprisingly, adequate security. And let's not forget, jobs in the technology will drive engineering education to include analytical problem solving and strengthen job growth in IT. Well, I hope you found this podcast interesting and informative. Clearly, there are many, many more areas of advancing and emerging technologies for electronics design, which I'll continue to cover in future podcasts. For information on this podcast, please be sure to check out the show notes. There you can find additional information related to this podcast, and you'll also find my email address. So feel free to send me your comments and questions or any topics you'd like to hear me talk about, or if you'd like to be my guest. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes or your favorite podcast app to catch the next episode of PCB Tech Talk.